Today we're going to study about scientific notation. What is scientific notation? Scientific notation is an easier way to write very large and very small numbers. A number in scientific notation is written as the product of a number between 1 and 10 and the power of 10. You write the power of 10 using exponents, with 10 as the base and the number of times 10 is a factor as the exponent, as shown. For example, I have 4.27 multiplied by 10 to the power of 7. This number is represented in scientific notation, and I need to write it in standard form. So the power of 10 tells you how many places to move the decimal point. Here, the exponent is 7. This means the decimal point has to move or has to jump to the right 7 times. So we have 4.2 multiplied by 10 to the power of 7. So we have here 4.2. And now the decimal point is going to jump 1, 2, 3, 4, 5, 6, and 7 places. And so we're going to put in zeros for the 7 jumps or the 7 gaps that the decimal point has jumped into. So 4.2 multiplied by 10 to the power of 7 will give me 42 million. Another example, a number written in scientific notation has 3 parts. This is part 1, known as the coefficient, multiplied by 10, which is the base, and it is always 10, and to the power of 4, which is the exponent. So the coefficient multiplied by 10, which is the base, and the exponent is the one that decides how many places the decimal point is going to move to the left or to the right. Below are a set of rules that should be followed. So here again we can say C times 10, where C represents the coefficient, the 10 is the base, and N is the exponent. So here C could be any number from 1 to 10, but shouldn't include 10. Alright, so it is a number from 1 to 10, and it could be a decimal. This is always the base, it is always 10, and the exponent must be an integer. It can't be a fraction, and it can't be a decimal. It can only be an integer. Now we're going to change a number from scientific notation to standard form. So the number of jumps the decimal point should jump is equal to the exponent. So when we see the exponent, it tells us how many jumps to the left or to the right the decimal point has to jump. If the exponent is positive, then the decimal point has to jump or move forwards to the right. If the exponent is negative, then the decimal point has to jump or move backwards or jump to the left. Here we have 3.128 multiplied by 10 cubed or 10 to the power of 3. This is in scientific notation. So here 10 to the power of 3, the exponent 3, means that my decimal point has to, and because it is positive, so the decimal point has to move forward 3 spaces or move 3 spaces to the right. So now if you can see, because it is 3, so it is 3 jumps. And here we have, it is 3.128. So the decimal is going to jump 1, as you can see, 2, and 3 spaces. So my final answer is 3,128. Another example, I have 6.4 multiplied by 10 to the power of 4. Here again, the exponent is 4. This means it has to be 4 jumps, and it is 4 jumps to the right, or we can say forward because the exponent is positive. So we have 6.4. So the jumps, let's see, the decimal point is going to jump 1, 2, 3, and 4 places. And so we will get an answer of 64,000. because each jump, the decimal point jumps, it leaves a gap. And if we don't have a number in this gap, so we fill it up with a 0. Now we're going to change again scientific notation to standard form. Scientific notation, we have 2 times 10 to the power of 9. So here 9 is positive. This means the exponent is positive, it's a 9. This means the decimal point has to jump 9 spaces. Or if there is no decimal point, then we can easily say that we have to add 9 zeros to the right of the number. So here you have 2, and we changed it into a decimal, so we say 2.0. And so we're going to move forward 9 times, or 9 steps. And each step we move forward, there will be a gap. We have to fill in this gap with a 0 as there's no other number. So the answer in standard form will be 2 billion. Now here we have a number given in standard form, 7,089,000, and we need to write it in scientific notation. Now here we do exactly the opposite. Earlier we were moving forwards when the exponent was positive. Now here what we will do is we're going to put a decimal point and we have to move backwards or move to the left. So we will write 7,089,000 as a product of 2 numbers. The first factor is the decimal number with 1 digit before the decimal, which is known as the coefficient. To write this number, we move the decimal point to the left 6 places. Then the second factor is a power of 10, which is the base, and the exponent is the number of places the decimal point was moved, as shown in the example below. So we have here standard form, we have 7,089,000. Now we need to write it in scientific notation. So here, as we said, that when we change a number in standard form into scientific notation, we can only have 1 digit in the ones place. And everything else has to be after the decimal point. So whatever the number is, we have only 1 digit in the ones place, and everything has to be after the decimal point. So here there is no decimal point, so we place the decimal point after the last 0. And we will move backwards as shown. So you see we're going to move 1, 2, 3, 4, 5, 6. So we move back 6 spaces and we place the decimal point behind the 7, meaning to the right of the 7. So 7.089, this will be our coefficient multiplied by 10, which is the base, and that never changes. And now we have to put the exponent or the power. The exponent is equal to the number of jumps. If we notice here, we jump backwards 6 steps. So my exponent has to be 6. So therefore, 7,089,000 will become 7.089 multiplied by 10 to the power of 6. Here we have another example. We're given the standard form is 40 billion. Now here again there is no decimal point, so we place our decimal point after the last 0, and then we have to move it backwards until we reach the first number on the left, and we put a decimal point right behind it. So if you can see here, we are going to jump 10 jumps. If we count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 jumps. So therefore, in scientific notation, we're going to get 4 as the coefficient multiplied by 10, which is the base that never changes. And because we moved backwards, or we jumped to the left 10 jumps or 10 spaces, so my exponent is going to be 10. Another example here, we have a decimal and or a number, a normal number, and we want to change it to scientific notation. So we move the decimal point left or right to arrange 1 digit to the left of the decimal point, meaning we have to move backwards or we have to move to the left until we have 1 digit only in the ones place. Always remember, in scientific notation, my only whole number is the ones digit. Everything else should be after the decimal point. So here, if I have 52,314 and I need to write it in scientific notation, I'm going to put the decimal point behind the 4, and then I will move backwards or to the left until I reach the 5. So my decimal point will move from the 4 to the 1, from 1 to 3, from 3 to 2, and from 2 to 5. So this means my decimal point has jumped 4 spaces backwards. So my answer is going to be 5.2314 multiplied by 10 to the power of 4, which is the number of places or jumps that the decimal point has moved. In the other example, I have 3.2. Here, if you notice, I have one digit in the ones place. So this means I already have the scientific notation, so I will not do anything. But if I need to change the 3.2 from standard form into scientific notation, 3.2 will be my coefficient multiplied by 10, which is the base. And because there were no jumps at all, so it will be 10 to the power of 0. And as you know from before, any base to the power of 0 equals 1. So 3.2 multiplied by 10 to the power of 0 means 3.2 multiplied by 1. So the number stays as it is. This is some work for you. Please do it. And if you have any questions, don't hesitate to ask. Have a nice day.